All right, we got the notes for law of sines. So law of sines is a series of equations that we can use to calculate the lengths or sides of a triangle, of angles in a triangle that does not contain a right angle. So Pythagorean theorem works for sides if we know our triangle has a right angle, but not all triangles do. So in order to use the law of sines, one of the following conditions must be met. You just know a corresponding angle side pair and any other value, whether that's angle or side, doesn't matter. Or you know a side in any two angles. Now, if you know a side in any two angles, that works because if you know two angles, you can always find the third, because all three angles in a triangle have to add up to 180. So we can always find the third angle. So in general, just for notation rules, angles are represented by capital letters, sides by lowercase letters, and the side is always across from its partner angle. So capital A here, lowercase a is the side across from it, angle B, capital B down here, lowercase b its angle across from it. So there's kind of two versions. It's a series of three fractions. Now, the one on the right is just the reciprocals of the one on the left. You usually use this one if we want to solve for an angle because it's usually easier to have your variable on the top. Now, if we are solving for an angle, there will actually be one extra step. That's where we'll have to use the inverse trig function to actually get the c or the b or the a by itself. So we only use two of the three fractions at a time. One fraction you just know both values in, so both a and little a and big A, and the other one you know one of the two values in. So for example, if I know little a, big A, and little b, I can find big B, and then I would not work with the c fraction at all. All right, so let's look at some examples here. Okay, so an angle JKL, little j, and big K. So how I like to do this is I like to organize it so capital letters are my angles, and then their corresponding sides over here. So, and then fill in the ones you know. So little j is 180, big J is 134, and big K is 7. Find little k. So I know an angle side pair, and I know one of these two values. So I can actually work out what little k is right now. I could actually also work out what big L is because the three angles have to add to 180. But I don't need to do that because I don't care about little l. So because I'm looking for a side, I'm going to do the version that has the sides on top. So this would be my equation. Now on the front page, we had A, B, and C, but the letters don't matter. So little j is 180, big J is 134, little k is my unknown, and big K is 7. So that would be my equation. Now we can do this all at once in our calculator because this is division then multiply across. So 180 divided by sine 134 times the sine of 7 will give us our answer instead of working out in a bunch of intermediate steps. So 180 divided by sine 134 times sine 7. So this is what it would, if it shows up on the screen, what it would look like. So our final answer is nearest tenth, so 1 decimal place. So little k would be 30.5. Okay, so triangle OPQ. So OPQ, partner sides O, P, and Q. And then fill in the ones that we know. Little p, 7.2, big P, 36, big Q, 38. Find the length of little q. So in this case, once again, we have our angle side pair. We're looking for this. So P over sine big P equals Q over sine big Q. So 7.2 over sine 36 equals little q, my unknown, over sine 38. Once again, we can do this all at once in our calculator. 7.2 divided by sine 36 times sine 38 to move it across. Sine 36 times sine 38. So little q, looks like a G, little q is 7.5. I'm also noticed angles and sides tend to scale, so 36 degrees gave me 7.2, so 38 is probably going to be just a little bit more than 7.2, which it was. So up here, 7 is way less than 134, so my side should be much smaller than 180. Okay, so triangle LMN, so little l, little m, little n. So let's see, we know little l is 870, we know that big N is 117, and we know that big L is actually 17. Find M. So I have my angle side pair, but in order to find little m, I need big M. Luckily enough, I can do that because, like I mentioned before, all three angles in a triangle have to add to 180. So I know that L plus M plus N has to be 180. So if I want angle M, I can just take 180 minus L minus N and get my answer. So M is going to be 180 minus 17 minus 117. So 180 minus 17 minus 117. So even though I don't directly need it, I know that that angle has to be 46. So now I can use my angle side pair. So little l over sine big L, little m over sine big M. So 870 over sine 17, little m over sine 46. So 870 divided by sine 17 times sine 46. So that gives me m is 2,100. Well, I've done something wrong. Oh, never mind. I'm okay. 2140.5. I'm sure that seemed awfully large, but little l is 870. M is bigger than it, so it's going to have to be bigger than 870. Now, they don't scale directly like m is about 3 times L. That doesn't necessarily mean little m is about 3 times little l. All right, last one here. So K, L, M, and their sides, little k, little l, little m. So little m is 59, big M is 139. So there's my angle side pair, and big K is 36. Find the length of little l. So just like before, in order to find little l, I need its partner, big L, but the three angles have to add to 180. So L is going to be 180 minus K minus M. So 180 minus 36 minus 139. So this is just a 5-degree angle. So don't directly need that answer, but still have to find it here. Okay, so let's see. So the frac pair we know. So M over sine M equals, what am I looking for? L over sine L. So 59 over sine 139 equals little l over sine 5. So 59 divided by sine 139 times sine 5. So little l to the nearest tenth, 7.8. And that brings us to the end of the section.